Think about how long it takes for a completely new technology to become normal. The personal computer took decades of gradual integration to reach mass adoption. The public internet moved faster in the 1990s, but society still had years to adjust workflows, build out the physical infrastructure, and draft regulations. This chart tracks the adoption curves of those technologies. Down here are the slow, steady climbs of the PC and the internet. And right here is generative AI. It captured 53% of the population in just 3 years. That speed means businesses are flying blind. We are drowning in hype with a severe lack of hard data to guide decisions. Produced by a steering committee of experts, the 2026 Stanford AI Index report provides the definitive reality check we need right now. Think of this report as a corporate balance sheet. For every measurable capability artificial intelligence gained this year, society was issued a massive hidden invoice. Look at the deposit side of that ledger. Global corporate spending on AI reached $581.7 billion in 2025. That is a 130% increase from the previous year. That capital is generating actual scientific utility. For the first time, an AI model successfully ran a weather forecasting pipeline end-to-end. It ingested raw, real-time meteorological observations and directly output final predictions for temperature, wind, and humidity. In astronomy, researchers built a foundation model that automates observations across 10 different telescopes simultaneously. We are seeing similar efficiency returns in healthcare. Across multiple hospital systems, AI tools that automatically generate clinical notes from patient visits have cut the time physicians spend writing documentation by 83%. The medical field is also developing data twins. These are dynamic, computational representations of individual patients that constantly update with new data to forecast outcomes and optimize specific treatments. The asset side of the ledger proves that AI has moved past the novelty chatbot phase. It functions as a highly effective engine for scaling scientific discovery and medical administration. But generating those capabilities requires a staggering amount of physical resources. To train a 2,816 tons of CO2 equivalent, that is the exact same amount of greenhouse gas produced by 17,000 cars driving for an entire year. To run these models, AI data center power capacity has scaled to 29.6 gigawatts. That is enough electricity to power the entire state of New York during peak demand. If you sum up the cumulative power demand of all AI systems globally, it rivals the total national electricity consumption of countries like Switzerland or Austria. Then there is the water required to cool those data servers, or run them off hydroelectricity. For GPT-4o alone, annual inference water use may exceed the drinking water needs of 12 million people. Every digital breakthrough depends on this physical industrial footprint, constrained by the same energy and water limits as any other heavy manufacturing sector. Historically, the United States has reliably outspent and outpaced every other region in model size, performance, and research output. This graph tracks AI performance. The U.S. lead evaporated as China matched top American models in 2025. Furthermore, international AI scholars moving to the U.S. dropped 89% since 2017, with an 80% drop last year alone. International borders regarding technical performance have dissolved, and the U.S. pipeline for top-tier talent is drying up. American dominance is no longer guaranteed. As laws require more resources and geopolitical stakes rise, the corporations building them are becoming more secretive. The index found that the most capable models often disclose the least amount of information. The Foundation Model Transparency Index saw average scores drop from 58 to 40 this year. Major companies are increasingly keeping training code, dataset sizes, and parameter counts to themselves. While companies protect their proprietary data, the predicted disruption to the human workforce is moving from theory to reality. This data visualization tracks software developer employment by age. While the headcount for older, senior developers continues to grow, employment for developers aged 22 to 25 has dropped nearly 20%. Executive surveys indicate that firms are prioritizing the efficiency of these models over recruiting and training the next generation of workers. You cannot afford to wait for government intervention to protect your role. Currently, U.S. public trust in the government to regulate artificial intelligence sits at a dismal 31%. In response, a massive global self-education wave is happening. Workers are bypassing formal education to rapidly teach themselves AI engineering and prompting skills. The experimental phase of artificial intelligence has ended. We are operating in a highly capable, wildly resource-hungry industrial era. Those who take the initiative to learn the tools will command the leverage. Those who wait for instructions will simply be written off the balance sheet.